Welcome to episode 323 of CppCast, the first podcast for C++ developers by C++ developers. I'm your host, Rob Irving, joined by my co-host, Jason Turner. Jason, how you doing today?
All right. How you doing?
Doing okay. So we're recording this one right before CppCon starts, but it should air, on like the last day of the conference, I guess. So,
yes.
Looking forward to it?
Yeah, tomorrow morning I give my class, and as I've already said many times, I am the only live on-site class at CppCon this year, and I'm pretty excited about it. I think it's probably the best class I've put together so far.
Yeah, so well, hopefully it'll go well. Obviously, we can't tell listeners to go sign up for it at this point because.
Well, I mean, if you really wanted to, you can. I mean, there's plenty of flights to Denver from all over the United States and Canada coming in regularly. The airport's almost back to normal capacity, I think, and I'm sure the Grizzly Rose, I keep pointing, the Gaylord still has rooms available. And if it doesn't, there's a bunch of satellite hotels, and you can go and sign up for my class right now. Although it would be too late. You're right.
It would be too late.
It would be a week too late. Crap.
Right.
I got all that wrong. You should edit that out, although you won't. So it'll be fine. Just make me look like
forget about the little time travel for a moment.
It's fine. But I am looking forward to this class, and I do think it'll be probably one of the best ones that I've done so far. So if you're listening to this in the future, because you can't listen to it now, then and you like the sound of this, then start talking to your company about having me out in 2022 to give training.
There you go. Okay, at the top of every episode, I like to read a piece of feedback. We got this tweet from Jacob saying, listening to CppCast and the talk about lifetime extension. This is always fun to read. And he posted this blog post about chained functions breaking reference lifetime extension. How did we talk about that with Hal again? When did that come up? Do you recall?
No.
Okay. Well, we'll put this post in the show notes so that other listeners can read it if they're interested.
In case you missed it, I've been preparing my class. I don't remember what happened a day ago.
That's fair. Well, we'd love to hear your thoughts about the show. You can always reach out to us on Facebook, Twitter, or email us at feedback@cppcast.com. And don't forget to leave us a review on iTunes or subscribe on YouTube. Joining us today is Bryce Adelstein Lelbach. Bryce has spent over a decade developing programming languages and software libraries. He is the HPC Programming Models Architect at NVIDIA, where he leads programming language standardization efforts and drives the technical roadmap for NVIDIA's HPC compilers and libraries. Bryce is passionate about C++ and is one of the leaders of the C++ community. He is the chair of the PL22, the U.S. Standards Committee for Programming Languages, and the Standard C++ Library Evolution Group. He also serves as editor for the INCITS Inclusive Terminology Guidelines. Bryce is the program chair for the C++ Now and CppCon conferences. On the C++ committee, he has personally worked on concurrency primitives, parallel algorithms, executors, and multidimensional arrays. He is one of the initial developers of the HPX parallel runtime system. Bryce, welcome back to the show.
Hello, it's good to see you guys again. Although I'll be very excited when we can all see each other in person.
Yeah, definitely.
Is it executors or executors?
It actually might be neither, because the current proposal that is the current direction does not actually have a thing in it called the executor anymore.
Oh,
okay. Well, we're gonna have to talk more about that, I think, right?
Yeah,
for sure.
It's a very C++ thing, but I always prefer to call it executors, not executor, because there's multiple of them. It's like you don't call it range, you call it ranges.
Sure.
That makes sense.
Okay, Bryce. Well, we got a couple news articles to discuss. Then we'll start talking more about kind of the latest news going on with the ISO and everything you're working on. Okay. All right. First one, we have a post on the SonarCube blog, and this is a Sonar Source blog, Supercharge your C++ analysis with SonarLint for CLion. And this post is from Phil. Phil Nash.
I think it's his first official act there was to write the article.
Yeah. And this is all about, I guess it's only been a little while that SonarLint has been available in CLion, and they're just going over some of the rules and inspections that come with that tool that, we'll show you what's going on with your code.
One that stands out to me as fascinating is it being able to recognize if you're using a possibly insecure hash or encryption thing and saying, hey, wait a minute, you might want to reconsider your hashing algorithm here or whatever.
Yeah, that was pretty.
That
cool.
was at the bottom.
I was pretty impressed by that, but it's like, it's not like it can really tell whether it's not going to always be able to tell whether it's like in a context where it matters or not, right? But it, like, still is pretty cool.
Yeah.
I think that the just the UI of their interface, I found pretty attractive. And like, I'm not usually a huge fan of like IDEs. I just use like BI, but I looked at that and I was like, yeah, that's like, I would use something like that.
And I think that, when we had the SonarLint people on here, they talked about how there is C-line integration, although it seems to be getting better. But another note on here is for any of these issues that SonarLint brings up, you can click on it and get like a full explanation as to why that check is there.
Yeah, like I found that like really useful for some of the, like, they use an example of one of the transparent comparators.
Yeah.
Like that's not, I don't expect most C++ programmers to like grok that just from like a one-line thing. So having it linked to, a full write-up of it is really, really helpful.
Yeah, and just so listeners know, on top of this C-Line plugin that we're talking about right now, they do have Visual Studio, VS Code, Eclipse, and I think these are all free with SonarLint.
I think that's right. Yeah, it's all their server-based stuff. So it's I think, no, maybe not on this one. Sorry, but yeah, I think those are all free.
Okay, next one, we have this blog post, efficiently searching an array with GCC, Clang, and ICC. And this is, going into some of the benefits of using stood algorithms over, writing your own, algorithms and some of the benefits from that, but also has a comment towards the bottom just about how everything's moving to Clang and how maybe that's not a great idea. I thought this was a good post.
Yeah, we often bring up how more diversity in the ecosystem is nice.
Yeah, it's I do think that it's a little perhaps concerning that so many compilers are moving towards Clang as a front end, especially because Clang's great, but everybody's like good happy memories about Clang are from 10 years ago when Clang was the new kid on the block. And there was this large production code base that had a lot of legacy that was in use everywhere, GCC, that, moved a bit slower. Now, 10 years later, Clang is sort of in the place in its lifetime where GCC was 10 years ago. It's not quite as agile as it once was. And in fact, it is lagging behind in implementation of some of the latest standard C++ features. And the code base has gotten to be very, very large and complex because it has so many different use cases that it has to serve. And like, I used to be able to navigate through the Clang code base, 7 years ago. And like, I've looked at it recently and it's a lot, there's a lot more there than there was.
Yeah. And I feel like even 5 years ago, if Clang and GCC disagreed on something, I just assumed Clang is right, GCC is wrong. And it was only 2 days ago that it took a little bit of effort, but I just had to prove to a friend, no, Clang is definitely the one wrong here. GCC is the one right. That is an outstanding bug in Clang. And it's one that I first noticed like 6 months ago. So
maybe I just run into more arcane compiler bugs than you, but I certainly run into my share of them that are been Clang ones. But that's why I sort of came to this realization that maybe Clang was no longer the new cool kid in the block when I was talking with Sean Baxter about Circle. Because like my first reaction when talking to Sean about Circle is like, hey, why did you go and write your own C++ front end? Like, nobody does that, right?
Why not
like,
build it on top of Clang?
Yeah. And he was like, well, I looked into it and like, it's a really big code base. And like, I just thought that I could write something that was cleaner myself, sort of from the ground up, that I'd understand better. And like, after talking with him a bit, I'm like, he's kind of right. Like, he kind of made the correct decision.
Although in 10 years, now Circle will be the slow moving kid on the block and someone else will pop up.
Then we'll have the Square compiler or something.
No, and I don't know. It's something, I feel like something changed in GCC. I don't know what changed, but it does seem that they are, like you pointed out, they're rolling out features faster than Clang is. Did they do something to make their code base more extensible, maintainable in some way, or is it just they're more determined right now?
They did. They started switching to using C++ internally some period of time ago.
Okay.
And I believe as part of that, they revamped a bunch of their internal data structures. And I think there's also just slightly more folks working on GCC now than there may have been a few years ago.
Right. That seems believable, yeah.
Yeah. Well, I don't know if we're going to get another compiler anytime soon that'll maybe take the place, but hopefully it doesn't go too much further.
LLVM's backend is just so incredibly helpful.
Yeah.
Because even Sean is taking advantage of LLVM's backend, right?
Circle.
Circle's just a front end, and it uses LLVM on the back end. Yeah.
Right. Okay, and then the last thing we have is write a post on our CPP, and this is C++ committee polling results for asynchronous programming. And it's great that we have you here, Bryce, to talk about this. We were, talking about executors a few minutes ago. This is more about the networking TS, and it looks like as of now it's somewhat stalled. Is that correct?
It's not dead.
It's not dead.
Yeah. I mean, I will say this: we definitely would like networking in the standard library. I think that's that still remains true. But we are not convinced that the networking TS is the right solution. So the networking TS has got to be one of our longest lived TSs now.
Oh goodness, yeah.
And prior to the networking TS, the committee spent some amount of time dabbling with just like inventing a networking interface out of thin air. Just inventing a new one, basically saying, hey, let's standardize networking. Let's just, go and create something of our own design. And then at some point, somebody's like, yeah, that's maybe not such a good idea. Let's just standardize Boost ASIO. And then that's sort of how the networking TS came about. But I think there's one frequent confusion here, which is that the networking TS is not really solely just a networking layer. It also contains the ASIO asynchrony model. And that's always been, it's always been linked to the actual networking interfaces. And to some degree, any networking API is going to inherently have some model for asynchrony these days. But because of that, because the networking TS had an asynchrony model, it was inevitable that it was going to come into conflict with other attempts to standardize an asynchrony model on the committee. Especially given that the committee tends to like consistency and unified models. And in fact, one of the polls that was not taken in that electronic polling period that was listed on Reddit, but my vice chair, Ben, included that result, was a question that I have been repeatedly asking Library Evolution over the past 6 to 8 months, which is, are we really confident that we must have a grand unified model for asynchrony in the standard library? Like a grand unified model that covers both structured concurrency and like compute asynchrony and like file and IO asynchrony and also networking asynchrony. Because like if we can agree to not do that, but like it's okay to have multiple models for different, areas, then it would make life a lot easier because we would no longer need to sort of pick a winner. But the committee did not bite on that. We did not have a clear consensus that we wanted to have a unified model. We definitely didn't have a clear consensus that we didn't want to have a unified model. And so that meant that inevitably we were going to have to pick a model. And we, so now that I've given them a little bit of the history of the networking TS, let's go to the executors. So executors has been an like 7-year-long project to standardize some framework for specifying, for parameterizing execution in the same way that we have allocators to parameterize allocation. We need some way to be able to say like, hey, I want to write some generic thing that will like create work somewhere. And then I want to be able to plug in different things, different types of executors that'll run work in different places and in different ways. So that was the basic idea. And back when it got started, in like the 2016 to 2018 period, there were originally 2 or 3 proposals, and including a proposal from Chris Kohlhoff, the fellow behind Boost ASIO. And at one of the Kona committee meetings, the committee said, y'all get together and come up with a joint proposal. And that was P0443. And I'm not entirely sure the exact moment that it went wrong. It wasn't like there was like one instant where it went badly. But it was just like, it started off as a just throw a bunch of authors together and make them compromise paper, which sometimes worked, sometimes didn't. In this case, I don't think it was as successful as we would have liked. And I remember even from the beginning, it was a little unpleasant because it didn't really compromise between the models. It just like took like the union of all of them. And it grew and grew over time. And it eventually ended up with this thing called properties, which was essentially a solution to not everyone being able to agree upon what was like fundamental aspects of an executor and like what were fundamental aspects of the interface. And at one point there was this whole interface adapting thing where essentially different people wanted to be able to write executors in different ways and then have them be adaptable to each other. Now, I will give you the inside perspective on how P0443 died. So last year around this time, we had just finished a review of P0443 in Library Evolution. And we got some feedback on the paper, how to like evolve it for like the next steps. And around that time, the main author of the proposal, Jared, who was at NVIDIA, he'd been working on this for a number of years, and he had sort of reached a point where he was no longer interested in working on this. And so we needed a new person to come in and take it over. And I had, for the most part, sort of been pretty hands-off about it because I was just like, like Jared's on it. I trust Jared. Like, it'll be fine. And I don't think that anybody other than Jared had realized how bad the situation had gotten with the proposal. And then like I started looking into the hood and I was like, oh, this is really like, this is not going to work at all. Like in particular for NVIDIA's use cases at the time, it did not, like the proposal that we were writing and authoring simply did not work. And the only way that it would work would be if we did things that were not specified in the proposal, that semantics that if we implemented it that way, it would be very surprising to people when they moved over to other platforms. And I had never particularly liked this approach. And so a few years earlier, there had been this senders and receivers proposal from Eric Niebler and Kirk Shoup and Louis Baker and Lee Howes from Facebook. And as soon as I'd seen that, I had a gut feeling that was going to be like the thing that we were going to end up, the direction we were going to end up going, because it was less of a train wreck than P0443. It was actually quite nice.
We've seen sender receiver models come up in all kinds of places, right? I mean, that's a fairly normal idea.
Yeah. And it was elegant. It had clean fundamental concepts. It was not birthed out of a compromise where nobody actually compromised. Like it had a clean underlying model, and that was the key selling point. And so it's like when I first saw that, like, which was 2 or 3 months before I came to join NVIDIA, my first reaction was like, I am gonna, at some point in my career, probably I'm gonna need to sell NVIDIA on this being like the model that we need to adopt. And so, so then last year, P0443 kind of fell apart. The main author left, and then we, NVIDIA, the folks that employed the main author, sort of realized, oh, this is not what we want to be doing. So I asked one of the people on my team, Mihal, I told him, drop all of the things that you're currently doing. Your full-time job is now this. And we started a once a week telecon with the senders receivers folks and some of the NVIDIA executors folks. And the first telecon, we were very far apart. And my approach was essentially just, I'm going to lock all of you in a room once a week until there's a proposal that comes out of this that we all agree on. And 6 months later, that proposal popped out, and that was P2300, and it was actually quite good. And it's based solely on senders and receivers.
I see.
And it sort of represents a paradigm shift in from NVIDIA's perspective, but I think it's a good paradigm shift because I think it's a better model for the standard library. But there was still the question of what do we do with the networking TS?
Right.
Because P2300 essentially ejected the parts of the compromise that were that were like needed by the networking TS. Because again, we wanted a very minimal core proposal, and we did not believe that those things were required. And so I had hoped that the committee might choose to see these things as being distinct, and that we could have the networking TS have its model and senders and receivers have its model. But it became clear that we were going to have to pick between the two. That was the only way forward. We could not even review either of the proposals, because the entire time we would spend discussing the proposals would be these existential debates about the underlying model. And we needed to get to a point where we could actually look at the details and do a detailed design review. And that meant that we had to pick one of the models and move forward with that model. And that is what we have done. And actually just this week, we had the first library evolution Super Telecon, which was Monday and Tuesday, which was 7 hours over the course of 2 days.
Wow.
And at the end of that 7-hour telecon, we took a poll, which was essentially, do you all want to sign up for another one of these super telecons and more meetings in like January to continue pursuing the goal of shipping senders and receivers in C++ 23? And we did have weak consensus that we want to do that. So the odds are not in our favor. We have essentially 3 months, and it is not at all clear that we will reach consensus on sending senders and receivers forward for C++23 by the design cutoff, which is February. But we have decided we would like to try. And so that we will be doing that.
Okay,
Well,
so I guess I should just say, we're going to hope that we do get this by February, but going back to networking, I guess the future plan of networking would be either to make a new proposal or to modify the proposal to work with this asynchrony model. Or are we not there yet?
Yes, I think that one of those two things would have to happen.
Okay.
And there's the separate question of security, which remains unaddressed and which has loomed over the networking TS for a while.
Right.
We do not have consensus that we're okay shipping networking without a secure layer.
SSL effectively.
Yeah. There's additionally a contingent on the committee that essentially only wants to ship secure sockets, that wants that to be the default. There's also another constituency on the committee that does not want to ship secure sockets, period, because of concerns about needing to roll out security updates and maybe having ABI breaks and whatnot.
Or just not being able to keep up with changes in security.
Yeah.
Right.
But the previous answer to this, which had essentially been, well, we'll ship security, like we won't deal with it in the first release. The first release will just have unsecure sockets. It's fairly clear that that's not going to fly. There was a very split vote on that question. And while the vote did not clearly say we must have security, the vote made it pretty clear that unless some work has been done to find a new compromise on the security question, networking is not going to happen. So that needs to be addressed, and that's going to be a tough one. And then we would, I think we would need to see a probably substantially modified networking TS. It is possible that could happen in time for C++26. I think if we're talking a new proposal, like a completely new proposal, I doubt that's a possibility. If we're talking about a retrofit of the networking TS, that's probably the best route forward, but that would require collaboration. That would require a group of people to collaborate. And the last time that collaboration was attempted, it led to P0443, which I do not think was a successful outcome.
Yeah.
So we'll keep trying. We're going to keep trying.
I want to read a comment here on the Reddit discussion, and it goes back to something that Bryce had just alluded to. If we agree to ship networking with a security protocol, is it planned to fix security issues if they imply an ABI break, or is it planned to explicitly never fix security issues if they imply an ABI break? Forget the security issues comment on here. When I read this comment and just thought about the last year of conversations that we've all been having about ABI, I personally went from like, oh yeah, I want to see networking in the standard to never mind. Don't put networking in the standard because it will never be allowed to change. And
well, I mean, we could also we could try this very bold thing of we could design the facility in such a way that it's ABI resilient. Like we're not gonna be able to design it in such a way that entirely prevents ourselves from being unable to change it in the future. Right. But we can, like, we're talking about an entirely new component. We should not take it as a given that it's going to be impossible to build it in a way that's going to be ABI resilient. Would there be a cost to that? Sure. Right. I think that the cost of I think that the cost is an acceptable cost.
Everything's a template.
Yeah, well, actually, it's more likely to be the other way around, that you'd essentially need to ensure that there's a layer of indirection.
Right.
Like take the classic example of Microsoft's STD mutex implementation, which
Right.
is like 10 times the size of their shared mutex implementation. If they had simply chosen to implement that instead of with the mutex bits in the class body, if they had instead said, hey, we'll always do an allocation and we'll put those bits in, this pointer somewhere, then they would have been able to make they'd be able to use the newer synchronization primitives on the newer platforms.
Right.
They'd have more options available to them. But they don't, because they did not want to put that extra layer of indirection in. And it's something that probably didn't even occur to folks at the time.
Right.
So just for a moment, you were just giving us this great inside baseball look at what would happen with executors. Since Jason just brought up ABI, can you tell us any bit about how the committee is looking at ABI these days? Because obviously there's the big paper a year and a half ago from Titus, and I think the vote just was kind of we're not going to change anything. Like, we're not going to make decisions on ABI. Is that look changing at all?
I do not think much has changed.
Okay.
I think that at the very least, I've been trying to turn the conversation more to how can we design for ABI resiliency, because that seems more productive. This is not. I do not think that we're going to solve this question on. Like, it's not going to be solved solely on policy.
Right.
I think it's pretty clear that we're deadlocked, at least partially deadlocked on policy. I think maybe if the conversation had been framed differently, we would have been less deadlocked. And so maybe we need to have that conversation again. It's a hard conversation to have without a face-to-face meeting.
Sure.
But the best way to dig ourselves out of this hole is to explore technical solutions. And like this networking TS security problem is a perfect example. It's a new library component. It's something that we're almost certain that we'll need to be able to evolve in the future. And so we should be exploring how we could build this thing in a way that is ABI resilient. And if the answer is that we don't think we can, then yeah, we shouldn't standardize things like that unless we do make the change of policy.
It does very much sound like between the asynchrony model needing to completely change and possibility of designing for ABI resilience, we're really no longer talking about Boost ASIO being merged into the standard. It's something different, or something with a very different API.
Yes, I think that's correct.
Okay.
And I have to be honest, I think the library evolution regulars have known this for a while, that ASIO wasn't going in as is. My predecessor, Titus, I like one of the last things he said to me in the context of him being Luke chair was something along the lines of, yeah, make sure you take a real careful look at the networking TS. I think specifically he was around the issue of object lifetimes. It's been pretty clear for a while that since the networking TS was shipped, best practices for some aspects of standard library design have changed. And so we knew that we would need to do a very comprehensive review of the networking TS, because it was put out, it was like designed and put out in 2016, 17, 18. And since then, the way that we design standard library interfaces has changed. But it's a really big proposal. And we've completely lost institutional knowledge of it. By which I mean the library evolution regulars, the people that I as chair rely upon to, review the papers. They do not have the knowledge of this 400-page thing that they'd need to be able to have a useful review of it. So that means that the starting point of the review has to be reteaching everybody what's in here. And then we have to do the actual review only after we've gotten to a point where we have enough knowledge to be able to like meaningfully make decisions.
Yeah.
And like that's just a massive commitment of time. And in hindsight, we had put the networking TS off to the study group, and the problem with putting it into a study group is that the study group audience is going to be much more self-selecting. In particular, it's not going to necessarily reflect the position of Library Evolution because the Library Evolution folks aren't going to be there. But the benefit of it, and the reason I'm glad that we did it, is we would be in a much worse shape now if Library Evolution had spent half of our time over the past 2 years reviewing the networking TS, only to discover at the end that we didn't really have an appetite for it. And I mean, it ended up becoming pretty clear that we didn't have an appetite for it, just directionally, just the fundamental model, not even having dug into the details.
Okay. So, we talked a lot about networking and STUD execution, but you said C++23, the feature freeze is early next year. What else do we think might make it in as far as big features go? How about
what did make it? Give us some good
or what
news.
made it already? Yeah.
Time for some good news. What did make it?
A bunch of Ranges work has made it in. Ranges has probably been the major success story of Library Evolution over the course of my tenure thus far. We have a lot of very active authors. We had a plan. I don't remember the paper number, but we can put it in the show notes later.
Sure.
And we had a plan for what we wanted to do, and there were priority levels of the plan. And it looks like we're going to do pretty much all of the things that are in the top tier of the plan. Some of the stuff that's in the lower tiers too. So there's a substantial number of Ranges fixes in C++23. Ditto for formatting. There's some other big Library Evolution features that are happening. Probably one of the more notable ones is that we will have a standard library module. It will be called STUD. We have determined that just having one big module is actually like pretty fast, because the way modules work, because it's not textual, you just pay really for what you use, because it's like an index, and just looks up in the index like, hey, you needed STUD vector, I'll go grab STUD vector now. Across a number of implementations, we've seen that having import STUD just as a catch-all is faster than like including only the headers that you need.
Now, to be clear, if I do import STUD, it's not the same as using namespace. I still have to do like std : to do things, right? I just want to make sure that's clear for everyone here. Okay.
Yeah. But yeah, so there'll be import STUD. It'll be really fast. It's probably going to be faster. Like, even if you have like very fine-grained header includes, it's probably going to be faster for you to just use import STUD.
Oh, wow.
And we've deferred the question of having finer-grained modules until later. I don't actually think we need finer-grained modules, because why would we if we have one big STUD module?
By the time you add 400 pages of networking to it, on the other hand.
Yeah, that's a fair point. But the costs shouldn't scale up that much in term for the size of the library. So then there's also I think we're calling it stud.compat. And stud.compat contains all of the namespace STUD names, but it also contains some of the things that sometimes get leaked into the global namespace, like int 64t. We made a decision that we wanted to fix the historical mistakes of the past and not pollute the global namespace and import STUD. So if you do import STUD, you're not going to have int 64t. You'll have STUD int 64t, but the only global name that you'll have in import STUD is operator new and operator delete.
Well, that's actually really interesting, because I mean, I just want to clarify this for the sake of our listeners too who don't know this. Like almost everything from the C standard library is intentionally or unintentionally imported into the global namespace. Right. So you can call, you can do #include cstdio and then just put puts or whatever. You don't have to do std : even though technically you need to namespace it. Right. Interesting. Okay.
Yeah. And perhaps amusingly, there is a feature test macro for import std. But if you import std, you will not have the feature test macro because modules do not import macros.
Wait, so you would have to first include part of the standard library, so to be able to do the feature test macro to know if you can import it.
Yep, you'd have to include version, and then you can check in there for the feature test macro. Yeah.
Okay. That makes sense.
Because we had to have them add a macro even for the feature that is like the anti-macro feature.
Wait a minute. So if you just do the import, you don't have any of the feature test macros, or do you?
You have none of the feature test macros. You have
interesting.
No macros.
So if you rely on that, you will have to still include version or
yes.
whatever.
Yes.
Okay.
So there's that, which is going to be a pretty big thing. I am fairly hopeful that we will have std generator. And I hope that the two authors who need to produce a revision of std generator are listening to this podcast and have heard me announce to the world that I am fairly hopeful that it will make it into C++ 23.
And this is, I'm sorry, for coroutines or?
Yeah, for coroutines, yes.
Okay.
So part of the coroutines library support.
Yeah, the coroutines library that we don't have really yet.
Yeah. Another big feature that's fairly likely to make it in is std mdspan, which is the multidimensional array abstraction. Std expected is also in.
It's in.
Yeah, it's in.
I missed that entirely.
Yeah. There's probably a couple others that I'm missing. There was a bunch of stuff that we kind of shipped to LWG in like the 2018-2019 period that were big things that that have only now just been processed. I think std expected was the biggest of them.
Okay.
And and then in terms of language features, the one thing that I know about is deducing this has made it in, which is fairly cool. And there's a bunch of context specification of a variety of different things. And there's also this cool thing that I believe is going into C++ 23, which is the ability to declare an entire class context. Yeah.
I missed that.
Yeah, so that's just some syntax sugar.
Right. We think we covered that paper months ago, Rob.
Okay.
When we were doing one of our paper roundups.
Yeah.
Yeah. And yeah, so that's sort of what C++ 23 is looking like. It's I think going to be at least a little bit larger than C++ 14 at this point. I also suspect that we will land a bunch more things that are already in flight between now and February. I don't know what's in the language evolution queue. But there is some possibility that we get senders and receivers in, which I think would make it probably a release more on the scale of C++ 17. Yeah.
I'm personally cool with a C++ 14 like release every now and then, because that was a great bug fix cleanup kind of release to the language. And
yeah, I would be okay with it if we did not have so much work to do. The pandemic slowed us down more than I would have liked. If not for the pandemic, it would not have been a bug fix release. It would have been a much more substantial release. And I think that is, I'm very proud of all that we were able to accomplish during the pandemic, but I think the fact that the pandemic did end up substantially changing the amount of work that we could do does not bode well for the future of our process. I'm very happy with how far we've come, how quickly we were able to adapt, but I think we needed to adapt even more.
Well, on that know, are there plans yet for in-person meetings early next year, or is it still unknown?
We were supposed to have a meeting in Portland, which got canceled in February. And we're supposed to have a meeting in New York next July, and we'll make a decision on that around March or so.
So one in February already had to be canceled. It's 4 months out. Wow.
Yeah.
Okay.
Well, we had a deadline by which if we didn't cancel, there would be a lot of fees, and and Herb asked. We did a poll of the committee chairs and like key staff to see who would be able to show up, and it became pretty clear that people were not going to be able to attend.
Okay.
Yeah. I think given the current direction of things, maybe it would have actually been fine, but at that time it was far too risky, and
we'll have to see.
Yeah, Delta was very scary.
If the beginning of November, we actually start to see more borders open and that kind of thing, we have to see what actually happens. I feel like I have to agree. I mean, yeah, you couldn't have risked losing the money for February. Yeah. That seems totally reasonable.
Okay. Well, I know we had a couple other features we maybe wanted to get a status update on. Has any work been done on reflection? Does that have a chance of getting into 23?
No. And it was never, we never expected it to get into 23. Yeah, no, zero chance of it getting into 23. At least as far as I know. You have to ask JF to be sure, but yeah, it's not. It was never even something we were targeting for 23. Ditto for pattern matching. I think both of those are possibilities for 26, but not for 23. There's let me say this delicately. There is some desire to put contracts into C++23. I think it is a wee bit late for that desire to be manifesting. So I think it is highly unlikely that we could see contracts in C++23, but it is a discussion that's being had. Yeah.
So I think there would have been a lot of motivation to like fix up contracts after it was dropped so last minute from C++20. Yeah,
there was, and there's been a lot of work on it, but I still think it's a little late.
Okay.
You said that you think that the committee maybe could have adapted a little bit more, and I'm kind of curious because if I understand your situation correctly, you both work a regular full-time job remotely and are on the committee remotely. And I've heard lots of discussion about how the committee was not able to get as much work done in a remote situation as they would have liked. How does that, sorry, I hit the mic. How does that differ or compare with a regular job? Like, what do you think the committee have done differently perhaps or not? Or do you think it's just too much of a big room environment?
I mean, honestly, running Library Evolution is easily 50% of my job, but it's probably more than that. Like it's consumed a very large chunk of my day job because it's had some unique challenges during the pandemic. Because essentially it's just like a full-time. I mean, we're actually meeting for less hours than we regularly would, but there's a lot more administrative work that has to be done. Yeah, I mean, I think the challenge we've had is it's just hard to get the time for the synchronous meetings, but the real problem is that we need to be able to review papers without having a telecon to look at them. And we've started doing some of that. We have, at least there is a route by which a paper can come in to Library Evolution, be seen solely on the telecon, be seen solely on a mailing list review, an email review, and then go straight to electronic polling without ever consuming any telecon time. That's something that we only really started at the start of the summer. But the email list is not, it's not really the right tool for this. And it's hard to get the level of engagement that we need. So, I mean, I think we would probably need something like a discourse or some sort of forum mechanism or something where it's a little bit easier to organize things. But it's really more of like a cultural shift than anything else. For us to really be effective, I probably need more. It's not so much that I need people to show up to telecons. It's probably more that I need people to go and review all of the less controversial papers that come in, and like send like out an email review with like, here are my thoughts, like +1, -1 on this. And it's just going to take time. It's just a culture change. It takes time. I think when JF and I started doing the telecons at the start of the pandemic, it was very explicit that in the paper, we did not ever call it a temporary measure because we never imagined the remote operations being a temporary thing. This was a modernization that needed to happen anyways. Yeah.
I've heard some banter on Twitter, and I'm going to almost wonder how I'm going to regret bringing this up because lots of things happen on Twitter. That part of the problem with your current scenario is when you're meeting in person, everyone who's interested in discussing the paper is there and able to vote. But with the remote telecons, I get the impression from Twitter that sometimes a vote goes one way or the other just because of who managed to show up to the remote telecon.
No, that's totally untrue. We have the same problem at the face-to-face meetings because, like, one, not everybody is there, and two, even if everybody is there, people aren't in the right room.
Okay.
Like it used to be a regular occurrence that we would have some vote, or somebody's paper would get presented with them not there, or we would want to review somebody's paper and the author wasn't there. And I mean, we do a lot of our polling electronically now. And that gives everybody a chance to participate. Although there is a fine balance between, like, it is sort of important that people be present for the discussions before, so that they can have an informed opinion when they vote. But yeah, the electronic polling mechanism I've been very happy with because one, it lets me figure out who voted how, and two, we ask people to provide comments so I can figure out why they actually voted. Because people are shy on telecon or in a meeting room.
Yeah.
You'll have a bunch of people who will have opinions, but they won't express them until they vote. And if the only way that they've expressed their opinion is that they've voted, and that you don't really know in a actual physical vote who voted how, that is a lot of information lost. So it's a huge difference in knowing, Bob voted, weekly against this for this reason that never came up in the discussion, versus like, why did 7 people vote weekly against this proposal, even though nobody, brought up issues with it when we were discussing it.
Right.
Yeah. But the problem of people not being present for all the discussions that they want to be is just a life problem. It's not a particular failure of the committee or anything. It's like, sometimes, a mistake is made and somebody forgets to tell people something or to make sure that somebody's invited there. And sometimes the person, is not paying as close attention to their emails or their calendar invites as perhaps they should be.
Right.
So it's a little bit on both sides.
Okay. Well, I think we might be running out of time. Bryce, is there anything else that you want to let us know about before we let you go today? We mentioned that you have your own podcast now, Bryce. You want to plug your own podcast?
Oh my gosh. Shit, Connor's not going to be filming me. Yes, Connor and I have a podcast called the Adsp Podcast, the Algorithms and Plus Data Structures Equals Programs podcast. We talk about a variety of topics, from the furniture in my apartment to APL, the programming language, to parallel algorithms, to like how to get through school, whether you should drop out of college, things like that. We just sort of like talk about like whatever. It's really just like an excuse for Connor and I to chit chat. once a week or so. And we're coming up on our 1 year anniversary, and we have big plans for the 1 year show.
Ooh.
Big plans. Yeah.
We did plug one of your episodes not too long ago when you had Sean Parent on and had him doing some storytelling. And I have a lot of respect for the way you did the episode, because it appears you had one convo with Sean and made like 3 episodes out of it. Is that right?
That's pretty much what we always do. We record for like 2 hours, and then Connor turns it into some number of episodes. Because like we don't go in with a plan. Like maybe sometimes there's a topic, but we just like go in and it's just like it's supposed to be natural, just 2 guys recording. But yeah, the Sean Parent episode, we do sometimes have, folks from tech, usually people who've been in the industry for a while, come in and like tell their stories. Sean Parent is our most frequent guest. And yeah, those are my favorites.
Okay. Well, it's great having you on again today, Bryce.
Yep. Great to be here.
Thanks for coming on.